If you see a function inside another function, this is what we call function composition. And if you see function composition, think chain rule. So how can we apply chain rule to find the derivative of tangent of sine x? Well, I'm going to let the outside function, so tangent, is going to be f. So y equals f of u, and I'm going to let u be this. Y equals f of u, and f was what again? Tangent. So tangent u. All right. And u was what again? U was sine x. But I'm also going to call the inside function g. So why am I using f and g? Well, what would happen if I went to this equation and I changed all the u's to g of x's? What would I get? Okay, so f of this gets changed to g of x, f of g of x is equal to tangent of, this gets changed to g of x again, tangent of g of x, which is the same thing as sine x. So tangent of sine x. This is the same thing as this. So basically, I decomposed this as two functions. Why are we decomposing again? Okay, so y equals f of g of x. We are decomposing to apply the chain rule. So if y is equal to f of g of x, according to the chain rule, what's y prime? It's going to be equal to the derivative of the outer, so f prime of g of x, times the derivative of the inner, so g prime of x. What's f prime according to this equation? What's the derivative of tangent? It's going to be secant squared. And what was g of x again? Sine x. Okay, times. So if g of x is equal to sine x, what's g prime of x? It would be the derivative of sine x, and the derivative of sine x is what? Cosine x. This is your answer. Now, follow-up question. Why did I use u and x here? I used u and x because, according to the chain rule, dy dx is equal to dy du times du dx. So this is the outer function. Derivative is equal to derivative of outer function times derivative of inner function. So what you get from this? Okay, and what was dy du again? Okay, so y equals tangent u, dy du would be secant squared of u, secant squared of u, and then times du dx. So if u is equal to sine x, what's du dx? Derivative of sine x is cosine x. Now we want dy dx, so we can only have x's here. We can't have any u's. What is u equal to? What can I change u to here, according to this equation? I can change it to sine x. Okay. This is your answer. And this is another way to show your work. Either way works. I like this one because it's slightly shorter.